Good morning, ladies and gentlemen. This is Mr. Rowe. We're taking a look in geometry, part A. This is lesson 12, and we're going to focus on the triangle inequality theorem. Now, this is written and discussed in the lesson, but I want to tell you in words kind of what it means as well, just so you'll have a verbal confirmation of what you should know. All right, so here is the triangle inequality theorem. So basically, it says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So in other words, if you have three measurements you're going to add to, it has to be bigger than the third. So to kind of explain this a little bit so you can see what I'm talking about, I've got this little short video clip here. And what I'm doing here is I'm using straws with different lengths, and I'm going to show you how some could be used to make a right triangle, or not a right triangle, to make a triangle, and others cannot. So I'm going to speed this up so we don't have to watch it at regular speed here. All right, so see, we've got some different measurements, and what I'm doing right here is I pick 10, 7, and 2. Could that make a triangle? We see, if you know, there's no way those three values would make a triangle because 7 plus 2 is 9. It's not bigger than 10. Same thing here. I picked the 3. 7 plus 3 is 10. It has to be bigger. It can't be equal to it. You see, if I pick the 4, then yeah, that made the triangle. So that's how the inequality theorem works. So I'm just going to show you some other quick values real quick. I've got 10, 7, and 6. Yes, that makes a triangle. So let's try 6, 3, and 2. Well, 3 plus 2 is 5. So it's not bigger than 6, so that can't work. But if I pick 4 and 3, 4 and 3, 7, that's bigger than 6, so yeah, I'm going to be able to make that triangle. See, that's how the inequality theorem works. So if I picked 4, 2, and 3, yeah, I could squeeze those together to make a triangle. So there you go. That's how the inequality theorem works. Let's take a look at some examples here of what we got going on. Can the set of numbers be used as measurements to construct a triangle? So this is going to be one of the ways we're going to apply the triangle inequality theorem. So I'm going to give you three numbers, like 25 plus 5, or 25, 5, and 27. And the question is, could these be used to construct a triangle? So how are we going to figure this out? Well, we're going to set up three inequalities and test to see if all three are true. So here's the first one. I'm going to take just the first two values, 25 plus 5. That has to be bigger than 27. Well, is that a true statement? What's 25 plus 5? That's 30. 30 is bigger than 27. So then I'm going to check the next set of values. So we'll put 5 and 27 together. What's 5 plus 27? Well, that's 32. Is 32 bigger than 25? Yes. So I'm going to check the last two just to make sure. So the last two would be putting 25 and 27 together. 25 plus 27 is 52. Well, we already knew this one was going to be true because 25 is already bigger than 5. But that is a true statement. So since all three inequalities are true, and we need to check all three in your work, show all three, then the measurements could be used to construct a triangle. Let's take a look at this example. So we've got 17, 14, and 36. Well, let's take a look at the first set. Is 17 plus 14 greater than 36? Well, what's 17 plus 14? That's 31. So in this case, I've already got a negative or an untrue statement. I've got 31 is not greater than 36. So I don't have to go any further on this one because I already know one of them doesn't work. So since one of the inequalities is not true, then the measurements could not be used to make a triangle. So those three values, 17, 14, and 36, could not be used. All right, so the last thing with this theorem that I want you to be able to do is to find some range of values. So I'm going to give you two, or we're going to determine the values of x that could be used as the third measurement. I'm going to give you two values and x. you have to determine the values for x that would make a third side of the triangle. So we're going to set up a compound inequality. And on the left side of the compound inequality, we're going to subtract the biggest value minus the smallest value, because we can't have negative values here. So we're not even going to go there with 7 minus 8. So it would be the biggest minus the smallest. On the other side, we're going to put the biggest, or we're going to add the two values together. It doesn't matter which one goes first. So what's 8 minus 7? That's 1. 8 plus 7 is 15. So that means x has to be a value between 1 and 15. It cannot be 1. It cannot be 15. How do I know that? There's not an equal sign here. It has to be bigger than 1, less than 15. Let's take a look at some more values here. What about 9, 9, and x? Same thing. Now, it doesn't matter. 9 minus 9 is how you're going to set it up. It doesn't matter which one goes first because they're the same. On the other side, 9 plus 9. Well, what's 9 minus 9? Well, that's 0. What's 9 plus 9? 18. Well, wait a minute, Mr. Ray. We've got a 0 here. We can't have a side of 0. That is correct. But this says that x has to be bigger than 0. So 0 is not a possible value for x. Anything bigger than 0. So just to the right of 0. It could be 0.001. That's bigger than 0, so it's not 0. So anything bigger than 0 is a value. And the x has to be less than 18. All right, so let's take a look at the final set here. What about 20 and 11 on x? So again, set the same type of inequality. 20 minus 11 on the left, 20 plus 11 on the right. What's 20 minus 11? Well, that's 9. What's 20 plus 11? Well, that's 31. So that means that x has to be values between 9 and 31. So 9 is less than x, which is less than 31. So I hope this helps you apply the triangle inequality theorem. If you struggle with this content, please let us know in a teacher message or make an appointment for a help